looking at this series problem, we want to decide if it's arithmetic or geometric. Now this isn't a sequence. Technically it's a series because of these plus signs here. But we want to decide, are they multiplying, which would indicate that it's a geometric series, or are they adding the same amount every time, which would be like a common difference. So looking at the denominator, which is the only thing that's changing, it looks like they're multiplying the denominator by 2. So that would lead me to believe that the common ratio, which is represented with an R, is 1/2. Now, if you're given some strange numbers where it's not as easy to see what's going on, what you could do is take that second term and divide it by the first term, and that would result in your common ratio. And of course you would want to check that to make sure that it is common between all the terms. So our first answer here is our series is geometric. The second thing that they want us to do is to write a recursive formula. Now, a recursive formula has 2 parts. The first part is to state what the first term in the series is. In this case, it's 1/2. We just look and see what the first term is. And so we indicate that with an a sub 1. Now, the second part of a recursive formula is to say how we get any other term. So we're going to say a sub n, which is just a generic. We can get any term by taking the previous term. So our a with a sub n minus 1 in the subscript is going to indicate we take the previous term and we multiply it by the common ratio, which in this case is 1/2. So that's just letting our reader know where to start that series and how to get each successive term. Next, they ask us about the explicit formula. Explicit formulas tend to be a little bit more useful for making calculations, and our explicit formula is going to be dependent on whether we have an arithmetic series or geometric. So here's the general form for a geometric series. It's always a sub n, so that's just generic. I can get any term by taking the first term in the series and multiplying by the common ratio, and that is raised to the power of n minus 1. So what we need to do to make an explicit formula that's specific to our series is to plug in our values. So we need to plug in our a1 value, which in this case is 1/2, and then our common ratio value also happens to be 1/2 in this case, and we need to raise it to the power of n minus 1. We're not going to plug in a value for n because this is a formula that anyone can use to find any term that they want. Now, n stands for the place that we're looking for in the pattern. So if I wanted to find the 100th number in the pattern, I would plug in 100 for n and make that calculation. So that is our final answer for the explicit formula. Now, the next question indicates that they want us to find the 15th number in the pattern, and I know that because the subscript on that a, which indicates a term, says 15. So we're going to use our explicit formula that we have above, and what we're going to do is plug in 15 for n. So we're making that substitution of 15 for the n. So we've got 1/2 times 1/2 raised to the 15 minus 1 power. Now you may want to plug this into your calculator, but just making some simplifications. I know that 15 minus 1 is going to be 14, so I really have 1/2 to the 14th power, but when I multiply by 1/2 again, I really have it to the 15th power again, so we can kind of separate that if we want to make a calculation that's a little bit easier. Now, if you plug this into your calculator, you may get a decimal, but if we start with a fraction, we really want to end with a fraction. So 1 to the 15th power is 1, and if I do 2 to the 15th power in my calculator, I get 32,768, and that is my final answer on that question for the 15th term. For our last problem, they want us to evaluate a geometric sequence, this summation. The summation is indicated by the sigma that's used here. And basically what they want us to do is they've given us the explicit formula for a particular geometric series, and they want us to evaluate the first through the 20th term summed together. So we could use our calculator for this, which I will show you in a different video. Otherwise, we can also use the sum formula for a geometric sequence, which is the sum is a1 times 1 minus r to the n power, all divided by 1 minus r. So just by looking at this formula, I can see that our r value is -2, and I also want to calculate what the first value would be in that series. So what I would want to do is plug in 1 for n. So 3 times -2 to the 1 power, excuse me, let me erase that, that should be a 1, would be -6. And we know that our n is 20 because that is the number that we're summing through. So I'm going to say s sub 20, which indicates the sum through the 20th number in the pattern. And we're going to put a1, which is -6, times 1 minus, and our is -2, and that needs to be raised to the 20th power. And then that entire thing gets divided by 1 minus -2. At that point, you may want to plug that into your calculator. And what I get is 2,097,150. And that is our final answer on that problem.